So today's lesson is called probability counting, probability using counting techniques, right? So I want you to think about all the possible things that we learned in the past unit, okay? So in the past, so I'm going to put that down here. In the past, what we studied was we studied factorials, we studied permutations, and permutations with clones. We also studied combinations. We studied using cases. We studied using tree diagrams. Okay, so we studied all those things. We also looked at set theory. Theory. Okay, now the basic concept of probability. All right, when you think of probability, it's in English, I would say it's what we want over everything in the simulation. Another way to look at it would be the success over all the outcomes that we have, which leads us to the basic equation. The probability of A is equal to NA over N of the outcomes, NS. So what I told you, now we need to move to the formula towards dealing with content concepts. So what I told you, we're going to use all of these possible types of counting ideas that we used from the past unit to solve our problems. So when we're looking at NA, we're looking at the number of success. And NS is, just like I said, is the number of all the outcomes that you possibly have. All right, now let's move on to our first problem. So we have 3 coins that are tossed, one right after the other, right? Calculate the probability that 3 heads will occur. So in order to do this, what I need you to do is I need you to think of, since we're having 3 coins being tossed, each coin can be tossed as a head or a tail. And we'll indicate the state of each coin by using the H or a T. So because we have a coin and each coin gets flipped, there are 3 stages. So let's use a tree diagram to show it. So we'll have stage 1 where the first coin is flipped. So I'll call this first coin flipped, the second coin flipped, and then the third coin flipped. So now we'll go over how this works. Imagine you're about to start your experiment. This is the root of the tree. And we flip the first coin. The first coin either has a heads or a tails. The second coin has a head or a tail for each of the possible events in the first column. So there's going to be 4 possibilities. And for after you flip the first head, you have a choice of either going to a head for the second one, and a tail for the second one. But then if you hit a tail, you have another choice of hitting a head or a tail for the second flip. So now let's go for the third flip. So for the third flip, if I went and had two H's, I could have an H or a T again, but now that H and T is connected to the first H. We do that again for the rest of them. So we literally have this tree finally created, and you'll notice that each branch ends up having two possibilities. We can use this tree to analyze each of the possibilities that happen. So let's take a look at the possibility of having three heads occurring. Please remember that when we're talking about the probability, it's the probability of what we want is equal to the number of times or the paths of what we want divided by the outcomes, the number of possibilities. Okay? So now, if you look at the final thing, when we're doing this, we're actually calculating how many paths we follow during the tree if I want to get three heads. So we start here and we follow the path all the way across, and you'll notice that there is exactly one path for finding exactly three heads. So for A, the probability of three H's, three H's is equal to, well, the number of possibilities. There's only one path. And then we're dividing by the total number of possibilities, which is 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So we divide it by 8, and then you would say, therefore, the probability is, and you would say 1 over 8. That's how we're going to write our probability statements when we've gotten our answer. For B, here's what happens. We have two heads, we have a head and then two tails, right? A head and two tails will occur. Now, when we're talking about the head and two tails occurring, we could have a head. We could have a head here, okay? And then we could have two tails. 1, 2 tails. But I never said that I couldn't have a tail to start, a head, and then ensure that I have a tail again, didn't I? And then I could do the same again for finding a tail. I could have another tail, but then I could ensure that I have a final head. So the probability of a head and two tails is determined by those three paths that we found. So we have 3 over 8 again. Therefore, the probability is, therefore, prob is, and we could write 3 over 8. So now here's C. When we do this next one, it says the probability that 2 coins are the same and the third is different. So I'm going to use, let's use the black marker this time to kind of match that. So when we're doing that, what we need is to go through all the possibilities of having the probability of 2 of the coins being the same. So we'll use the black highlighter to kind of show that. So in this case, we start here. We have a head, and then we could have, say, another head, and then finally choose a tail. So we go head to tail. Then we could have head and then tail and then head again. That's 2 spots. So we couldn't have head, tail, and then tail, but now we could have a tail to start and then a second tail, and then the third would be a head. Then you could have a tail followed by a head and then followed by a tail again. Now, so those are pretty easy. But let's say that we started with a head, we started with a tail, and ended with, we could have started with a tail, right? Got another head, and then got one more head. And if you take a look, there's only one that we're missing. So what would happen if I had a tail followed by a head, a tail, a head followed by a tail, followed by another tail? So that gives us a total of exactly 6 possibilities. 6 possibilities out of 8, which reduces to 3/4. Therefore, the probability is 3/4, and we're done. Now, we can do this problem again, but this time, what we could do it with is using the placeholder method. I'm going to do this in black to isolate it from the first solution using trees. So the key idea here is to start by identifying all the possible outcomes that you have. So that is NS. And NS is equal to, well, there's 3 possible outcomes, right? And for that 3 possible outcomes, you have 2 choices for each one. So the 2 choices are head and tails, head and tails, and head and tails again. So times those 3, which gives us a total of 8 outcomes, okay, for NS. Now, for part A, I want to know the probability of A. So aside, what you'd do is you'd go and calculate the possibility of a head and 2 tails occurring. No, 3 heads occurring. So that's literally HHH, which is exactly 1 times 1 times 1. So the probability is 1/8, just like we expected, because we take the number of possibilities, which is 1, then we divide by 8, so we end up with 1/8. So now let's take a look at our next possible problem. The next possible problem is, it's saying that we have a head and 2 tails will occur. Now, in this case, you got to remember that when they say a head and 2 tails, it could be a head and 2 tails, or it could be a tail and a head and a tail and a head, I guess. So the last one would be 2 tails and a head. So that's 3 possibilities. So you could show that on a piece of paper, but let's say that the numbers were too big, right? The key idea would be to go and say, all right, there's 3 spots, but then there are 2 tails that are matching. We can't identify them. So these are our T's. When you do your calculations, you're dividing those out. So you end up with 3 factorial divided by 2 factorial, which is 3. So the probability of this thing, of this new one, is the probability of a head and 2 tails is equal to the number of ways, which is here, 3, divided by the total number, which is 8. So now, for the last problem here, you've got C. We've got the probability of 2 of them being the same out of the 3. Probability of 2 of the same. Now, imagine that I had done what we had done before, but that time we did it for tails. That's for 2 tails, right? But the same calculation can be done for two heads, which means that the number of possibilities is 3 for the number for two tails happening, and then 3 again for two heads happening. And then we divide by the total number of possibilities, which is just, well, turns into 6 over 8, which is just 3 over 4, which is what we would do for that final problem. And just make sure that you go and change this. This is not supposed to say a tree diagram. Make sure this says that this is the placeholder method. Now, both methods are useful. I would say this one here for a small number of possibilities is excellent. But when we have a bigger set of possibilities, let's say we had 50 coins, right? And 48 of those coins were heads, then you would have to do the placeholder method because drawing the tree would be very cumbersome. And so now let's move on to our next problem of the day. So a box contains 4 blue pens and 6 red pens. If order is important, so the moment that it says order is important, we have to recognize, children, you got to recognize that this is permutations, right? Unless I explicitly say that order is important, you're going to have to figure that out yourself, right? This time, order is important for our sets, right? If order is important and you make 2 successive draws, then determine the probability of drawing 2 red pens. Okay. Because when we do 2 successive draws, it means that order is important. But if it was just pull out 2 pens, order is not important in that case. But this time it is. So we're going to use permutations. So remember, permutations for n of s. Remember, we're only pulling out 2 pens, right? So basically that is a total number of pens is blue and 6. So the total number is 10 P2. Now, you could have also done this using the placeholder method by just basically taking 10 times 9, which gives us a total of 90 ways we can pull out 2 pens. So that's NS. So we'll kind of keep that off to the side here and use that for our calculations. So now we need to figure out the probability of having 2 pens. So the probability of having 2 pens is A. So 2 red pens exactly. So probability of 2 red. Okay, so remember, the denominator of this thing is always going to be 90 because that's the total number of outcomes. But we need to calculate how many ways we can get 2 red pens. So the n of 2r is just going to be, well, if we use the placeholder method. So placeholder method means we have, well, 6 times 5 pens, which is 30. So that's 30 over 90, which gives us a final answer of 1/3. And then you would say, therefore, the probability is 1/3. Okay, let's write that properly. So let's go and take a look at B. What is the probability of drawing 2 blue pens? 2 blue pens, the probability of 2 blue is the same calculation that we did up there. Now remember, the denominator is always going to be 90 because that's the total number of ways. But then we need to calculate the possibility of 2 blue. So n of 2 blue, instead of doing it using the placeholder method, we can use the permutation method. So we have, well, 4 blue, and we're going to choose, and we're going to pick 2 of them, which gives us 12 over 90, which gives us 12. So our answer is 12 over 90, which simplifies to 2 over 15. And we have our answers. Okay. And just like this one, we also have our answer. So now all we have to do is write our final calculation. Therefore, probability is 2 over 15. So now the last problem that we have here, C. For part C, it's asking what the probability of drawing one of each. The probability of drawing one of each. Okay, so we can do this using the placeholder method or permutation. So the probability of 1 red and 1 blue, and what we can do is we can calculate it using the placeholder method. So we go red and then blue, which is just, well, for my red, there are 6 possibilities. And then for the blue one, we have 4 possibilities, which gives us 24. Now, that's one answer, one way to get the answer. I could also do it this way. N of R and B happening together is literally going to be, well, it's going to be, well, for R, it'd be 6P1 times 4P1, which gives us 24. So remember the probability always, the total outcomes is 90, so that's the bottom, and we end up with 24 on the top, which turns into just 4 over 15 when we reduce. Therefore, the probability is 4 over 15. And we're done. So now let's move on to the next problem. So here's an example. We have Brandon Raul, and Olivia are betting on European football. At the start of the season, they need to pick 4 teams, and they need to determine the probability of winning if they have to pick the top 4 teams in order of ranking from 1st to 4th. And they have to pick the top 4 teams where order doesn't matter. So firstly, let's focus on part A. All right. So they have to pick the top 4 where there has to be an order. So that means this is permutations, because we actually need to do our permutations to get our possible answers. So the number of S for A is going to be, well, if you think about it, there are 30 teams, right? In every soccer league. So let's just make sure we have that up here. So 30 teams. So we start with 30 teams, and then we pick them in descending order. So 30, then 29, then 20, 28, then 27, which is just P4, which gives us the total of 657,720, right? Now we need to calculate the possibility of what we're looking for, which is our number of teams. Our number of teams our numbers that we choose, n of s, n of a, is going to be, well, if you think about it, we have placeholders of first, second, third, and fourth. Okay, now, since we have all those placeholders, right, there's only one way you can pick third, one way you can pick second, one way you can pick third, and one way you can pick fourth. So there's only one way to calculate that. So the probability is going to be 1 over our massive number, 657,720. And there is our answer. And there's our answer right there. That's our probability. So now let's go and calculate for B. For B, you're going to recognize that ranking does not matter. So the ranking doesn't matter in this case, right? So this is a combination calculation. So because it's a combination type calculation, we have to calculate n of s equaling, well, 30 teams, and we're going to choose only 4 of them because we don't care what places they come. So that turns out to be 27,405. So now, in order to figure out what n of a is, because we don't really care what the order is, we can use our placeholder method. So for the first slot, there is 4 ways. For the second slot, there is 3 ways. For the third slot, there's two possibilities left over, and then 1. So just multiply those out, and you end up with 24. So the probability of A happening is literally going to be just 24 over 27,405. Now, you can leave it as that fraction, or you can change each of these into percentages for when we're doing these calculations, because the percentages tend to be more representative of what the certainty of this is going to be. So you can usually leave it as a percentage for these final answers. But leaving them as 24 over whatever is still acceptable. But in a real world situation, I would expect you to say that the probability of winning is something, and the probability of winning is. So for the first problem, you're going to have the probability of winning is 0.00015%. And finally, for the final problem, you can say the chance of winning is approximately 0.09%. And we're done. So now let's talk about how we're going to do this problem here. Recall that sometimes when you're doing combinations, so if I had NCR here, I get tired by writing of NCR. You can also write it as NR in this stacked form for any calculations that we want. So sometimes I do that in order to cut down on the amount of work I have to do. So let's look at this problem. So here's our example. MDM4U has decided to create a committee of 5 to honor their THEIR wonderful teacher through various festivities. If 15 students consisting of 3 gentlemen and 12 ladies are in the class, determine the probability that the committee is made up of only 5 ladies. So let's go through this and calculate NS. N of S, remember, we had, you got to think of it. You got to think of the guy. You have to think of males and the females that are in the total amount of people. And then we're only going to be choosing 5 of them. Okay, so the number of males and females is 12 and 3. Choose 5 because it's the number of ways, right? So now we have 15, choose 5, which gives us this answer here, 3003. Now, if you haven't figured it out yet, anytime we're doing groupings of people for which we don't have their names or anything, these are combinations in order to find N of S, N of A, stuff like that, okay? So that is what we get for NS. You could have just started with 15, choose 5, get your answer, right? So now let us do part A. So for part A, find the probability that the committee will only be made up of ladies, right? So we're going to write P of ladies. No, let's just use F and M like we were setting before. So F, P of F is equal to the N of F divided by the N of the total. All right, so now it says, what is the possibility of only being made up of ladies? So in order to figure this out, you have to use what we call the hypergeometric distribution. That's where we have some sort of combination of calculations on the top and some combination on the bottom. Now, in order to make up our 5 guys, our guys and girls, we have to look at it as this. We have 3 boys, 3 males, and 12 females, right? And then we're dividing by our combinations that we calculated before. That's 3003. Now, when you do these problems, I want you to clearly indicate that these are the males and these are the females, so that when I look at your solution, I can see where you're getting your choices from. So in this case, if there's only females, there are 0 males in our group. And then I pick only 5. I only choose 5 girls from the other group. So that gives us the final answer of, well, 3 choose 0 is 1 times 792 divided by, well, 3003. So that would give us our final answer of about, when you simplify it, so what is the probability? You can leave it as a fraction, which simplifies to 24 over 91. Therefore, P of F is that. So now that we've gone through the long way of doing this, let's see what we can do for the B value, and then we'll make another page and do C's separately. So for B, now it says the probability that the committee will be made up of 2 gentlemen, P of 2 males, and 3 females. Well, that is literally the N of 3F and 3F and 2M, or 2M and 3F. It's up to you. Divided by n of s. So now we're going to do the same calculation that we did before, where we have 3 choices and 12 from the other, divided by our 3003 that we had before. Now, make sure you identify M for males and F for females, and then fill out the total number of males. So in this case, we have 2 and 3. And that simplifies to 3 choose 2 gives us 3. And then we're timesing that by 12. And that gives us 220. And then we divide that by 3003. Now, 3 divided by 3003, we can cancel this. And this, so we got 1 over 1001, which gives our probability of 220 over 1001, which simplifies to 20 over 91. So therefore the probability of 2 males and 3 females is given by that. And now we will just highlight our final answer for both. And we're done for part A and B. Part C will be much more time consuming, so we'll do that on a separate page. All right, so let's review what we have here for our problem, okay? So we literally have a committee made up of 5 people, right? There's 3 gentlemen and 12 ladies, a total of 15 people, right? Now, what we want to do for part C here is we want to find the probability that the committee will have at least 1 gentleman. Now, in order to do this problem, you could do this in cases where you would go and find the probability of 1 gentleman, the probability of 2 gentlemen, the probability of 3 gentlemen, right? You could do that. That's the long way. Which would be that. Do all those calculations, find all the numbers for the number of male, number of 2 males, number of 3 males, number of 4 males, number of 5 males, and then add those all up, and then, oh my God, it just takes forever. But what if you could do this indirectly? Method, okay? So if you did this problem indirectly, we have to understand what we don't want, right? In this case, you want the number of 0 men. And that's because we need to know how many men, how many ways we can get absolutely no men. So that's this. N of 0 men is equal to, well, remember, it was 3 choose something and then 12 choose something, right? In this case, we're going to choose 0 and then 5 women. Multiply that out and you end up with 792 ways. Make sure you identify that these are your men and these are your female. So there's 792 ways for us not to have a men. To not have a man is 792 ways. Now, we now need for our indirect method, so we've got that. So now we need, so let's call that part A. Part B, we need the total with no restrictions. The number of people with the number of ways with no restrictions. No restrictions. Okay, so I'm actually going to write this down. So that is n of s, which was 15, choose 5 from before, and we got 3003. So now to find at least 5 men, at least, not 5 men, but m being greater than or equal to 1, what we have to do is we have to take 3003 minus 792. So that is our n of m being greater than or equal to 1 is this, which gives us our final answer of 2,211. So n of m greater than or equal to 1 is that, right? Now, let's go back to our description of probability. So this is part C. We're going to state the probability, right? So P of at least one man greater than or equal to 1 is equal to the n of 0 men. No, not 0 men, which is the n of m being greater than or equal to 1 divided by n of s, which is 2,211 divided by 3,003. And that is our probability, which simplifies to 67 over 91 is our probability of males greater than or equal to 1 with at least one male. So therefore, the probability of getting at least one man is at least one man is 67 out of 91. And we're done. Your homework is online. What I'd like you to do is you're going to do all the questions that I gave you. And I will also provide some extra practice problems as we need to practice this stuff and really get it. So today is just practicing how to do these problems.